Dear students, in last class you have learnt how to write the transfer function for an analog low-pass Chebyshev filter. Today we will see how to write order of analog low-pass Chebyshev filter. Order of analog Chebyshev filter is cos h inverse of 1 by as square minus 1 divided by 1 by ap square minus 1 whole raised to half. Divided by cos h inverse of omega s by omega p, where as is gain or magnitude at stop band frequency omega s, and ap is gain or magnitude at passband frequency. Omega p. If n1 is in fraction or in decimal number, then we have to convert that to nearest positive higher integer, and then we have to call it as capital N. Next we will see frequency response of analog Chebyshev filter of type 1. For odd n in the passband, the magnitude starts from AP and it oscillates between 1 and AP. And in the stop band, the gain decreases monotonically. That is, there are no ripples in the stop band. Only the ripples are found in passband. That is why it is type 1 analog low pass Chebyshev filter. That is why these two are the frequency responses of analog low pass Chebyshev filter of type 1. Now we will take problems on designing of digital Chebyshev type 1 filters. Example: design a Chebyshev digital IIR low pass filter using impulse invariant transformation by taking capital T equal to 1 second to satisfy the following specifications. The magnitude in the passband varies between 0.9 to 1, whereas the width of passband is 0 to 0.25 pi, and the magnitude is less than 0.24 in the stop band. So these are the given specifications to us. To satisfy these specifications, we have to design a Chebyshev digital IIR low pass filter using impulse invariant transformation taking capital T, that is sampling time equal to 1 second. Like in case of designing Butterworth filters, here also first we will write the specifications of digital IIR low pass filter, and then we will transform the frequencies of digital filter into the frequencies of analog filter, keeping the magnitudes as they are using impulse invariant transformation. Then we will calculate the order of the filter. Using order of the filter, we will write for the analog low pass filters transfer function. Solution: passband edge digital frequency omega p is equal to 0.25 pi radians per sample. Stop band edge digital frequency omega s equal to 0.5 pi radians per sample. Gain in normal value at passband edge is equal to 0.9 and gain in normal value at stop band edge is equal to 0.24. Sampling time capital T is equal to 1 second. Next we will write the specifications of analog low pass filter These are specifications of digital filter. Gain in normal value at passband edge. This value won't change for digital and analog filter. Similarly, gain in normal value at stop and edge will also not change. We have to keep them as they are. Gain in normal value at passband edge is 0.9. Gain in normal value at stop and edge is equal to 0.24. Now we have to transform digital frequencies into analog frequencies using the frequency relationships in impulse invariant transformation. That is, passband edge analog frequency omega p. For a Chebyshev filter, omega p is equal to omega c. That is, passband edge frequency and cutoff frequency both are same. That is equal to digital frequency by sampling time, that is capital T, which is equal to once again 0.25 pi radians per second. Unit of analog frequency is radians per second. Stop and edge analog frequency omega s is equal to digital stop and edge frequency by sampling time, and that is equal to 0.5 pi radians per second. Now we can calculate order of the filter N1. Order of the filter N1 is equal to cos h inverse of 1 upon as square minus 1 upon 1 upon ap square minus 1 whole raised to half whole divided by cos h inverse of omega s by omega p, that is equal to cos h inverse of 1 upon 0.24 square minus 1 upon 1 upon 0.9 square minus 1 whole raised to half whole divided by cos h inverse of 0.5 pi upon 0.25 pi. Simplifying, we get n1 equal to 2.1077. Rounding off, we can write order of the filter as 3 because 3 is an integer higher than and closer to 2.1077. We know that when n is odd, normalized transfer function h of Sn of Chebyshev low pass analog filter is B0 upon S plus C0, product of Bk by Sn square plus Bk into Sn plus Ck for k equal to 1 to n minus 1 by 2. Here n minus 1 by 2 is 3 minus 1 by 2, that is 2 by 2 equal to 1. So we will have here capital B1, here small b1, here we will have small c1 and b0 c0 here. To calculate the values of bk and ck, we need to calculate the value of yn, and yn is given by half into flower bracket into square bracket into round bracket. Inside the round bracket we have to write 1 upon epsilon square plus 1 raised to half, round bracket complete, plus 1 upon epsilon square bracket complete raised to 1 upon capital N, that is order of the filter, minus. Now we have to repeat the square bracket and round bracket, but power will be 1 upon minus n or minus 1 upon n, that is 1 upon epsilon square plus 1 whole square plus 1 upon epsilon raised to minus 1 upon n, flower bracket complete, and epsilon value is given by (1 by ap square minus 1 raised to half), that is equal to 1 upon 0.9 square minus 1 raised to half. Simplifying, we get 0.4843. Using epsilon value equal to 0.4843, now we have to calculate yn. So yn is equal to half into flower bracket, square bracket, round bracket, 1 upon 0.4843 square plus 1 raised to half plus 1 upon 0.4843 square bracket complete raised to 1 upon 3 minus square bracket round bracket 1 upon 0.4843 whole square plus 1 raised to half plus 1 upon 0.4843 raised to minus 1 by 3. Flower bracket complete. If we simplify, you will get yn equal to 0.5107. In last class, we have studied that C0 equal to yn. Therefore, C0 will be now 5107. Now, we have to calculate bk. bk is what? bk is equal to 2 times yn sine of 2k minus 1 pi upon 2n. So substituting the value of yn, k and n and converting this angle in degrees, we get 2 times 0.5107 into sine of 2 into 1 minus 1 upon 2 into 3 into pi into 180 upon pi, that is equal to 0.5107 only. But for k equal to 1, bk is equal to what? bk is equal to b1. Next, we have to calculate ck value. Ck is equal to yn square plus cos square 2k minus 1 into pi divided by 2n, that is equal to 0.5107 square plus cos square of 2 into 1 minus 1 into pi into 180 by pi by 2 into 3, that is equal to 1.0108. But again k equal to 1, therefore ck is nothing but c1. To find bk value, we have to equate h of Sn at Sn equal to 0 to 1 for n an odd number. Therefore, h of Sn will become b0 into bk divided by c0 into ck equal to 1. That is b0 into bk is equal to c0 into ck into 1. And we know what are the c0 and ck values. Here in this example, we have bk as b1 and ck as c1. Therefore, b0 into b1 equal to c0 into c1. C0 is 0.5107 and C1 is 1.0108. Taking B0 equal to B1 equal to B2 equal to dash 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 up to B n minus 1 by 2, we get B0 equal to B1 equal to under root 0.5107 into 1.0108, and that becomes 0.7185. Now we will make use of capital B0, capital B1, small b1, c0 and c1 in the expression for h of Sn and obtain the normalized transfer function h of Sn. H of Sn is equal to b0 upon Sn plus c0 into b1 upon Sn square plus b1 into Sn plus c1. Substituting for b0, b1, we get 0.7185 into 0.7185 in denominator Sn plus c0. The value of c0 is 0.5107. Sn square plus 0.5107 Sn plus c1, and c1 value is 1.0108. Point 7185 into 0.7185, we get 0.5162. Multiplying the polynomials in Sn in the denominator, we get Sn cube plus 1.0214 Sn square plus 1.2716 Sn plus the constant term is 0.5162. So this is normalized transfer function of analog IIR low pass filter. To obtain unnormalized transfer function h of s, we have to substitute for Sn equal to s by omega c. But omega c is equal to omega p, and that is equal to 0.7854 radians per second. Now h of s equal to h of Sn at Sn equal to s by omega c, that is equal to s by 0.7854. So h of s is equal to 0.5162 divided by s by 0.7854 whole cube plus 1.0214 s by 0.7854 whole square plus 1.2716 s by 0.7854 plus 0.5162. Taking LCM and simplifying, we get h of s equal to 0.2501 whole divided by s cube plus 0.8022 s square plus 0.7844 s plus 0.2501. To convert h of s into h of z using IIT, we have to make use of partial fraction expansion, that is h of s equal to 0.2501 divided by s plus 0.4011 into s square plus 0.4011 s plus 0.6235. Now this may be written as a upon s plus 0.4011 plus bs plus c divided by s square plus 0.4011 s plus 0.6235. We are writing here bs plus c because in the denominator we are having quadratic polynomial in s. Cross multiplying and simplifying, we get 0.2501 equal to a into the bracket s square plus 0.4011 s plus 0.6235 plus bs plus c into s plus 0.4011. Multiplying and further simplifying, we get 0.2501 equal to as square plus 0.4011 as plus 0.6235 a plus bs square plus 0.4011 bs plus cs plus 0.4011 into c. Now equating the coefficients of s square, s and constants on LHS and RHS, we can write we insert here one line equating corresponding coefficients on LHS and RHS a plus b equal to 0 because coefficient of s square are a and b, and here we don't have s square term, and here on LHS we don't have s square term, so a plus b is equal to 0, or we can write a equal to minus b. Now equating the coefficients of s on LHS and RHS, 0.4011 a plus 0.4011 b plus c equal to 0. Now we can put here a equal to minus b and simplify. Minus 0.4011 b plus 0.4011b plus c equal to 0. Here we are having coefficients of b equal but with opposite signs. So they will cancel each other, hence c becomes equal to 0. Now equating constants on LHS and RHS, we get 0.6235a plus 0.4011c equal to 0.2501. 0.6235a plus 0.4011c equal to 0.2501. But we know that c is equal to 0, therefore a will be equal to 0.2501 by 0.6235. And that is equal to 0.4011. Therefore b is equal to minus 0.4011. Now substituting for a, b, c in h of s, we get 0.4011 divided by s plus 0.4011 plus minus 0.4011 s plus 0 because c value is 0 whole divided by s square plus 0.4011 s plus 0.6235. In the second term of h of s here, we will complete the square in denominator and rewrite the denominator as h of s equal to 0.4011 upon s plus 0.4011 minus 0.4011 into s divided by s square plus 2 into 0.2006 s plus 0.2006 square plus 0.6235 minus 0.2006 whole square. Square of this square root term, that is equal to 0.4011 by s plus 0.4011 minus 0.4011 by s square plus 2 into 0.2006 s plus 0.2006 square plus 0.5832. that is equal to 0.4011 upon s plus 0.4011 minus 0.4011 s divided by s plus 0.2006 whole square, because these three terms together will now be equal to s plus 0.2006 bracket whole square plus this 0.5832 we can write as 0.7637 whole square. We will add and subtract this 0.2006 in the numerator and keep the denominator as it is. Now taking denominator separately to s plus 0.2006 and 0.2006, s plus 0.2006 by s plus 0.2006 whole square plus 0.7637 whole square. Minus into minus will become plus 0.2006 divided by s plus 0.2006 whole square plus 0.7637 whole square. Now this third term in h of s we will write in standard form 0.4011 divided by s plus 0.4011 minus 0.4011 into s plus 0.2006 upon s plus 0.2006 whole square plus 0.7637 whole square plus, here is shortage of place, therefore I will write 0.4011 into 0.2006, one below the other, divided by s plus 0.2006 whole square plus 0.7637 whole square. Now further simplifying and multiplying and dividing the third term by 0.7637, we get 0.08046 divided by 0.7637 into 0.7637 divided by s plus 0.2006 whole square plus 0.7637 whole square. Now we will understand in what standard form the second term and third term are there. Second term is in s plus a upon s plus a whole square plus b square form, and the third term is in b upon s plus a whole square plus b square form, whose z transform we can write directly. Before we write the z transform, we will simplify h of s further to get 0.4011 upon s plus 0.4011 minus 0.4011 into s plus 0.2006 upon s plus 0.2006 whole square plus 0.7637 whole square plus 0.1054 into 0.7637 divided by s plus 0.2006 whole square plus 0.7637 whole square. Now using standard h of s and h of z relationships, that is s plus a upon s plus a whole square plus b square gets transformed into 1 minus e raised to minus a into capital T into cos of bt into z raised to minus 1 whole divided by 1 minus 2 into e raised to minus at into cos bt into z raised to minus 1 plus e raised to minus 2 at into z raised to minus 2 and b upon s plus a whole square plus b square gets transformed into e raised to minus at into sine of bt into z raised to minus 1 whole divided by 1 minus 2 into e raised to minus at into cos bt into z raised to minus 1 plus e raised to minus 2at into z raised to minus 2. Now we know what are the values of a, t and b. Substituting these, we can get z transform of h of s directly. Therefore, h of z is equal to 0.4011 upon 1 minus e raised to minus 0.4011 into z raised to minus 1. This is z transform of 0.4011 upon s plus 0.4011. ai upon s plus pi gets transformed into ai upon 1 minus e raised to minus pi into t into z raised to minus 1. So using this relationship, we are writing for Z transform of 0.4011 upon S plus 0.4011. And for these second term and third terms, we'll make use of these standard relationships. So minus 0.4011 into the bracket 1 minus e raised to minus 0.2006 into 1 into cos of 0.7637 into 1. This angle we have to convert into degrees into z raised to minus 1 divided by 1 minus e raised to minus 0.2006 into 1 into cos of 0.7637 into 1, that will be 0.7637 only, into z raised to minus 1 plus e raised to minus 2 into 0.2006 into 1 into z raised to minus 2. Plus 0.1054 into e raised to minus 0.2006 into 1 into sine of 0.7637 into 1. Again we have to convert this angle into degrees into z raised to minus 1 whole divided by 1 minus e raised to minus 0.2006 into 1 into cos of 0.7637 into 1 will remain same into z raised to minus 1 plus e raised to minus 2 into 0.2006 into 1 into z raised to minus 2. Simplifying by taking LCM, we get h of z equal to 0.0906 z raised to minus 1 plus 0.0698 z raised to minus 2 whole divided by 1 minus 1.8516 z raised to minus 1 plus 1.4611 z raised to minus 2 minus 0.4484 z raised to minus 3. So this is the transfer function of required digital filter. I will stop the class here and continue in next class. Thank you.